Right. All right. You are. Okay. And we're live. Is that good? All right. So, the last section in this chapter is the difference between these two ideas, proportional and non proportional. I don't know, maybe you have an idea about one of these? Yeah? Like one you're willing to talk about or one you're willing to you got something you want to add? I don't know. Okay. Okay. I would agree with that statement. And in fact, we can actually use that thought if we tie this back into section 3.4, the one you guys watched on Tuesday about direct variations. They talked about ratios that would continue to be equal to each other. That's going to play back in here today. Okay. So in your notes, we're going to separate into these two. All right. So that we can kind of look at the difference. We're going to look at, once we kind of lay out the difference between these two, we're going to look at 4 problems and then that's it. Yeah, they're going to follow these two ideas. So we're just going to list some things about what it means to be proportional. We're going to list some things about what it means to be non-proportional. We're going to look at 4 questions and we're going to make the determination. Is it proportional or is it non-proportional? Okay. That's going to be kind of the plan for today. So we're going to let that go. Ultimately, our goal is to be able to write an equation. So if we can establish what it means to be proportional, then what does an equation have to look like for that? And if we can establish it to be non-proportional, can we write an equation to look like that? All right. So here is like a cutout from your book that kind of describes what it means to be proportional. So what I'd like you to do is just take a second, read through that, and then we're going to list what you think it means to be proportional. Why do you keep looking at me? You are. Like you keep staring at me. Oh, well, read. So as you look through there, in order to be proportional, tell me something that's got to be true. Yeah, no, I would agree with that. However, though, what is when you say it goes up by the same value, are you talking about there being a slope? I don't know. Okay. Yeah. Okay. It is going up by 3 every time. I would agree with you there. Does that's just because these have a constant increase, right? And so do the x's. Doesn't guarantee that it would be proportional, but there is something special about those ordered pairs. Okay, so there's one kicker for a proportional relationship. So number 1 on your list would be that it must pass through the origin. So put that down. Like what is Aubrey, you got to focus. So that should be your first statement. It's got to pass through the origin. Okay, it is linear. I'd agree with you. Now that is going to be the only statement that shows up on both sides of this board that they're both linear. Okay, because everything in this chapter is linear. Yes. Yep. Yeah. If you go back in your notes to section 3.4, you'll find that. Every single time that you do the same y divided by x, you're getting the same answer every time. Do you remember what that's called? Good. So in a proportional relationship, it has what's known as a constant of variation. And that constant of variation is known as k, but it's written as, or it's found by looking at y divided by x. So if you come back, like you said, Faith, to this chart, every one of these relationships produces the same answer every single time. And in fact, that value that it produces is that value that's right there inside of the equation. Okay. Now, if I'm going to write an equation for a proportional relationship, what's it going to look like? Any idea? Y equals, yeah, look at you. Absolutely. Well, you know what? Y is equal to K times X. And that K, right, that constant of variation can be found by looking at that relationship every single time, right? Or we said the other day that K was really your slope, right? What are you talking about? Here. Is that what you're talking about? So the ratio of the value of y-x is constant because here, when you do anything divided by 0, it's not possible. So what we're saying is excluding this point. Everything else will follow that same relationship. This one won't. It never would because you can't do 0 divided by 0. Okay, that's a good question, right? Why is there the difference between the two, right? In a non-proportional relationship, all right, let's finish that and then hopefully we can draw those two ideas together. But you're right on, like why two things? That doesn't make sense, right? If proportional relationships have to pass through the origin, then non-proportional relationships don't, right? I mean, like, so that's kind of the big kicker there, right? Non-proportional relationships do not pass through the origin. They do still have to be linear, but they are not going to go through 0, 0. 100%, right? Because that's what you should be looking for. You should be looking either graphically to see if it goes through the origin, or if you're looking at a table of values, is the order pair 0, 0 a part of it or not? Like, that's what you should be focusing on. What's up? Yes. Yep. Okay. So if you're going to write a non-proportional relationship, then what equation are we going to use? Because we're not going to use y equals k times x. So Ruby, I think you kind of hit on this. We're going to use, so y equals mx plus b, right? And so if I heard you correctly, it was like, well, yk over here and ym over there, when in fact they're kind of really similar to the same idea. And I'll give you, hopefully this helps. If I took this table of values, and let's say we just said 1, 2, 3, 4, and over here we used, I don't know, 3, 7, 11, and 15, let's say. Is that linear? How do you know? Okay, so in your x values, they go up by 4 every time. And in your y values, they go up by 1. So we would say that this has a slope of 4 over 1, right? It doesn't have a constant of variation because if you look at y divided by x, you don't get the same answer every time that you would in something like this. So if we took the same x values, but this time we used 4, 8, 12, and 16, these ones all produce the same number. They are. Yes, they are. Right? What is 3 divided by 1? What is 7 divided by 2? 3.5. 11 divided by 3? I don't know either. Right? Okay. All right. And 15 divided by 4? The point is, every time you do that, you produce a different result. However, this is still a picture of a straight line. But over here, every single time you do this, they get the same number. Okay. If you backed this one up, oh, seriously, you're all hooked. All right. If I took this away and I put the XY up here, what would be the next ordered pair here? Okay. So because 0, 0 is a part of it, it's proportional. Over here, if you backed this one up, obviously that's a 0, but this is a -1. So still a linear line, but doesn't go through the origin. and doesn't have a constant of variation, but still has a slope. You can. You really can. Because really, what are you missing on this one? What's not here? Your B. But your B is representing your y-intercept. And in this situation, your y-intercept is always going to be what? 0. So do you really have to write it? No. Okay, so hopefully that. So basically, if you can follow the path backwards and say yes, it would be in there, then you can do that. Now, remember though, this one originally did not have it. So if you wanted to, you could look at and say, well, what if I look at y divided by x? Like 4 divided by 1, 8 divided by 2, 12 divided by 3, still give me the same number. So here, I'm going to use the formula y equals kx because I know that k has to be a 4 because that result was 4, that one was 4, that one was 4, right down the line. Over here, I'm going to use mx plus b, and I got to answer two things. What's the slope and what's the y-intercept? Now, can you tell me what my slope is over here on this one? What's y doing every time? And what's x doing every time? So it has the same, slope value, except over here, I need a y-intercept as well because it's not going to be 0. And it's going to be -1. It's this one here when x is 0 and y has a value. So -1. All right. So we're going to look at 4 questions. 2 of them are tables, 2 of them are graphs. You're just simply going to tell me, is it proportional or is it not? And then what's the equation? And then we're done. So here's number 1. We can graph it if we need to, but if we don't have to, we don't need to do that. So as you look at that table of values, your question is kind of like, would it go through the origin? Would it not? Right? Do my ratios of y divided by x, do they come out to be the same thing every time? Or do they not? So Ian, you're saying yes? Okay. So if that's true, then it's guaranteed that it's got to fit that form. So all you got to be able to tell me is, what's k? And it's 50, right? Every single time it's 50 divided by 1, 100 divided by 2, those all give you an answer of 50. Or if you came backwards, that's not going to show up very well. 0 and 0 would definitely be the next ordered pair in that path. So this equation would be y equals 50x. Done. Not too hard, is it? Okay. So how about this one? You just got to know what k is. Yep. This is not. Okay. So if that's true, then that means it's non-proportional. So you have to be able to tell me what's your slope and what's your y-intercept. You got to be able to give me both. I put the table here. Maybe if it's easier if we put those in. I don't know. Maybe. So like the first one you see is 1 and 1. And then 2 and 4. 3, 7, 4, 10. And 5, that would have to be a 13, right? I wasn't going to say that. I didn't want to put you on,
That's okay.
3 over 2? Oh, what's this change right here? 3. What's this change? 1. So maybe 3 over 1? Be careful. These are counting by 2s. So you got to be careful there. So I think our slope is 3 over 1 or 3. Uh-huh. You went from here to which point? From this one? So from here to there. So this is 6 over 2. Yeah, see why it's not nice when they don't count by the same interval? You got to be careful with that. All right. So what's your y-intercept though? Where is this line going to end up? At -2? If you have a straight edge and you draw it through, you could see it that way, right? Remember, that vertical scale is counting by 2, so it does look like it's going to be, or you could do it right off here, 5, 4, 3, 2, 1, that's a 0. -3 from here, you'd get -2, so your equation would have to be at -2. So you can kind of look at that either way. All right. Here's number 3. What do you think? Yes or no? Proportional or not? So if you can quickly say proportional, then you're just trying to tell me what k is equal to. And whether you look at it as the previous ordered pair here would be zeros, or whether you look at the y divided by x, every time there you're going to end up with the same statement that it's 1.5x. So heaven forbid this ever happened. Use the equation in part B to predict the number of miles you walk in 8 hours. That would be terrible. I would just sit down and hope somebody pick me up. Okay? If you had to walk for 8 hours at this pace, how far would you make it?
Why would you walk for
I don't know. Maybe you're lost in the desert. No. 1.5 times 8, your answer better be bigger than 8. 12. Huh? If you want, so you'd have to put an 8 in there for x. So yeah, it'd be 12 hours. All right, last one. Is that proportional or not? Okay.
Oh, it doesn't pass in 0.
Right. If it does, then you say yes. If it does not, yeah. So I think like if you have the ability to make a straight edge, like that's what you should use. So you can quickly see now that that answer is a no. So you have to use which equation? Y equals, you got to use mx plus b. Now, just looking at the picture, I think you could tell me your y-intercept just by looking at it. Where does it cross the y-axis? I mean, it's right there at 1. So you know that this is going to end with a +1. We just need to figure out what's your slope. You think 3/2? Yeah. Well, so if I started here, I could go from there to there, from there to there. So how many am I going up and how many am I going over every time? And it does look like that result would be 3/2, or truly anything that's equivalent to 3/2. So whether that be 6/4, 9/6, any of those would still work.
So when you did it, like you went 3/2 each time.
Right.
You go from the point that's in the positive up to the other point, like a third.
Like from here to there?
Yeah.
Sure.
Oh, because then it simplifies that.
Right. So yeah, 1, 2, 3. So that's 6/4, which still works. All right. Any of those would work. Okay. So not that you're going to look at a ton. You're going to look at 6 questions. We have plenty of time for you to finish before you leave. Okay. The very first question is going to ask you to graph. If you want to graph so that you can see the picture, then by all means do that. If you can recognize which one of these two relationships you're dealing with without graphing it, then you don't need to graph it.